Welcome to this tutorial. I'm solving question number 11 of paper 2 May-June exam series of 2019, and the topic of this question is mainly radioactivity and decay equations. Part A says stars are formed inside a cloud of gas and dust in space. When a star forms, the cloud first becomes smaller as it collapses. State what causes the gas cloud to collapse. So the reason of this collapse is gravitational attraction of particles. So gravitational attraction causes it to collapse. In the next part, it says eventually nuclear fusion occurs in stars. State two conditions required for nuclear fusion to occur in the star. So the first condition is high pressure is needed so that the two lighter nuclei are forced to combine, and secondly, very high temperature is needed for this reaction to start. The next part says when a large star explodes, nuclei of heavy elements are formed. On such nucleus, one such nucleus is uranium-235. State the name and the number of each type of particle found in one nucleus of uranium-235-92. So first particle could be proton here, and the count of this particle is 92, and the other particle found in the nucleus is neutron, and the count is obtained when we subtract 92 from 235, and the answer is 143. State one feature that is the same for the nuclei of all the isotopes of uranium. So all the isotopes of uranium have same number of protons or electrons. A nucleus of uranium-235-92 in a nuclear reactor can undergo nuclear fission. Describe the process of nuclear fission in a nuclear reactor. So there are two main steps. Number one, a neutron hits the nucleus of uranium and is absorbed by the nucleus, which makes the nucleus unstable. So then the nucleus splits and emits more neutrons. Smaller nuclei are also formed, and huge amount of energy is also released during the process. State one difference between nuclear fusion and nuclear fission. So there are many differences. One could be that a fusion is joining two smaller nuclei, while fission is splitting up of a large nuclei or nucleus. The next part says the nucleus of uranium-235-92 is not stable. It decays by the emission of an alpha particle into a nucleus of thorium. Complete the nuclear equation that represents this decay. So first of all, for the alpha particle, the mass number is going to be equal to 4 because an alpha particle is similar to a helium nuclei. So it contains 2 protons and 2 neutrons. Secondly, for the thorium, we are going to subtract 2 from 92. So the remaining protons for the thorium would be 90. And we are going to subtract 4 from this 235. So the remaining mass number for thorium is going to be 231. Giger and Master carried out an experiment to investigate the scattering of alpha particles. Figure 11.1 shows a diagram of the apparatus that they use. So they used a radioactive source which created a beam of alpha particles. Then there was vacuum in this area. A thin gold foil was placed in the way of alpha particles and a fluorescent screen was set up all around this apparatus. When an alpha particle strikes the fluorescent screen, a flash of light is emitted. On figure 11.1, mark with a letter P where most flashes occur on the screen. So we know that in this experiment, most of the alpha particles, they were able to pass straight through the gold foil because the atoms of the gold have large spaces amongst them. So most of the alpha particles, they went undeflected. So most of the flashes were seen behind the gold foil or the place which was right at the back of the gold foil. Describe what is seen on the other parts of the screen. So on the other parts of the screen, we see very small number of flashes or fewer flashes. Most of the flashes were right behind the screen. State 2 conclusions about the atoms of gold that resulted from this experiment. So the first conclusion was that nucleus is very small, and the second conclusion was most of the atoms mass is concentrated, most of the atom's mass is concentrated at the center of the atom called nucleus. Okay, so the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.